Yes, welcome yet again to my second presentation. I'm so delighted. So my model is the automated police signaler. And yes, we've got. Yes, I'm going to be presenting to you my problem, the data set I've chosen, and the factors why I've chosen the data set. I'll tell you about the different features in my data set. I will describe for you Bayesian theorem, naive Bayes, Bayesian networks, the differences between Bayesian theorem and naive Bayes, the differences between naive Bayes and Bayesian networks, and of course, I'll give you the differences. So my problem, our model is going to work as a human scream detector to control crime rate in our communities. The crime is the biggest social problem of our society, which is spreading day by day. And I believe with my model, which will be signaling to the police in case of any crime, we shall see the police come through more efficiently and quicker in terms of crime. Thousands of crimes are being committed every day, and still many are occurring right now all over the world. And I believe with this automated police signaler that will be able to detect human scream, I believe we're going to curb that crime rate. And my data set, I've given you the link to my data set. It's called the Scream data set. And this data set has been used for an automated police signaler model using machine learning and AI technology. Well, the data given in the data set is useful if one wants to segregate noisy audio from human screams. This is where the AI will apply, in that it will be able to differentiate between human screams and any other loud noise. Now, we have given this data set happens to have a variety of sounds, and this is to help train our model. In case it hears any sounds, it has to be able to differentiate between human scream and noisy sounds. All right. Then our factors I've considered to choose this data set. Number one, data type. I considered the fact that my model uses audio data, hence a data set had to have that. I couldn't choose any other data set that was either using figures or text, stuff like that. The size of the data set matters, in that once the size of the training data set is not enough, it usually results in too poor estimations. In the problem type, the problems had to be similar, in that the data set has to be purposed to fulfill the given goal. Yes. And the data set features I'm looking at are sample width, which is the number of bytes per sample, sample rate, which is the frequency of samples used, the frame width, which is the number of bytes for each frame, the length, which is the audio file in milliseconds, the frame count, which is the number of frames from the sample, plus also the intensity, which is the loudness of the sound. Bayesian theorem was named after an Englishman called Thomas Bayes. Describes the probability of an event based on prior knowledge of conditions that might be related to the event. Yes, and I go on to state for you what Bayesian theorem is. Then I give you an example, which is the interesting part. For example, if the risk of developing health problems is known to increase with age, Bayesian came through, and it allows the risk to an individual of a known age to be assessed more accurately. That is by conditioning it on their age, than simply assuming that the individual is typical of the population as a whole, which makes it more understandable. Bayesian theorem is also used widely in machine learning, where it is a simple, effective way to predict classes with precision and accuracy. The Bayesian method of calculating conditional probabilities is used in machine learning applications that involve classification of tasks. Well, I move on to naive Bayes. Naive Bayes is a simplified version of Bayesian theorem. It is considered a quick and simple algorithm in solving various classification problems. It separates data into different classes according to the Bayesian theorem, along with the assumption that all predictors are independent of one another. Well, I'll give you an example of this. For example, you can consider a fruit to be a watermelon if it is green, round, and has a 10-inch diameter. These features could depend on each other for their existence, but each one of them independently contributes to the probability that the fruit under consideration is a watermelon. That is why the classifier has the term naive in its name even, right? Bayesian networks working on data or statistics, you will know one thing for sure, that correlation does not necessarily mean or imply causation. Humans focus their mathematical efforts on probabilistic and statistical inferences, leaving causal considerations to the mercy of intuition and good judgment. Imagine. Bayesian networks make it easy for us. They help us distinguish correlations from causation by allowing us to see various independent causes at once. I'll give you an example. For example, in the spam filter, this I didn't know, but in the spam filter, Gmail filters spam emails. Those are the unwanted and unsolicited emails, as it uses the Bayesian spam filter, which is the most robust filter. Just good to know this. Wow. Well, moving on, the differences between Bayesian theorem and naive Bayes. Bayes theorem does not, assume conditional independence, while naive Bayes assumes conditional independence. Bayes theorem, its algorithm is slower as compared to the naive Bayes. For the Bayes theorem, executes simpler modes as compared to the naive Bayes. Moving on to naive Bayes and Bayesian networks, their differences are naive Bayes is a bit restricted or constrained, while the Bayesian network is more general in how it works. Then naive Bayes is simple, while the Bayesian network is more complicated. Bayesian network is a bit slower, while the naive Bayes is even faster at classification of tasks. Well, thank you. Well, I'll sum up with the references. I tried to highlight, I gave you my Kaggle, where I got my Scream data set from Kaggle. Yes, I wanted to give you many, where I got most of my data from. I want to appreciate you for this opportunity. Thank you.